Okay, this lesson is called Integration by Parts. Substitution, when we did use substitution, that was a way to solve some integration problems, and most of the time those problems involved the chain rule. Integration by parts involves like the backwards product or quotient rule. It's kind of a strange rule. There's a couple ways to do it. So let me show it to you first, and then I'll try to show you some tricks if I can. So the formula for integration by parts is uv minus the integral of v u prime. What this means is when you're looking at a problem and you solve it by parts, you're going to pick out a u in the problem, you're going to pick out a v prime, and after you pick these things out, you're going to find the derivative of u, you're going to find the antiderivative of v, and then you're going to use this formula. It's a little bit more complicated because there's more things to pick out, but the process is kind of simple, and especially once I show you there's a trick for it, for some of them, not for all of them, but for some of them. So the first example, the integral of x cosine of 2x. Alright, when you're trying to pick what u is and what v is, there's this little saying or mnemonic. It's L-I-A-T-E. And it's called Liate, but it tells you what to pick for u. So in the problem, if there's a ln, that's the first thing that u should be. If there's not a ln, then you go to the I. The I stands for inverse trig. If there's like an arcsine or arctan, that would be the next thing you would pick. The A stands for algebra, so like an x or an x squared or an x to the third. T stands for trig, and E stands for exponential. So you look in the problem and you look at the two things or three things that are in the problem, and whichever one comes first in Liate, that's the one that u is. So in this problem we have algebra and we have trig. Algebra comes before trig in Liate, so u is going to be the algebra. And then v prime is going to be the trig part. So then u prime is 1. I just find the derivative. Now I'm going to have to find the antiderivative here. And technically you're doing u substitution when you're doing this part of it. If you just know what the antiderivative is, that's fine, or if you need to think about it. If u is 2x, du would be 2, so there would be a 1/2 on the outside. So the antiderivative of cosine of 2x would be 1/2 sine of 2x. Now I use the formula. uv, and I multiply it together, minus the integral of v u prime. Now, what happens when you do this uv minus vu prime thing is the second integral becomes easier to solve because the algebra has gone away. So now, if you want to take the 1/2 outside, you can, or just like not think about that part right there. The integral of sine of 2x would be negative 1/2 cosine of 2x. So then my answer, I'll leave this alone, x over 2 sine of 2x minus, alright, we got that 1/2, but then the antiderivative is negative 1/2 sine of 2x. And this is all running together. I'll write it on the next page. X over 2 sine of 2x, and then plus 1/4 cosine of 2x plus c. So that's the answer on that problem. Okay, let's look at another example. Alright, think about Lyautey. The x is the algebra. The e to the negative 4x is exponential. The algebra comes first, so u is going to be the x. Whichever one comes first, that's the u. V prime is e to the negative 4x. Alright, find u prime, the derivative. Find v, which is the antiderivative. Alright, you got to think about u substitution in that power. U's negative 4x, du's negative 4. So there's a negative 1/4 on the outside, and then the antiderivative. Now do the formula. uv minus the integral of v u prime. So it's negative 1/4 e to the negative 4x. Bring all that down, but I'm going to simplify this next one a little bit just to make it easier. I'm going to take that 1/4 on the outside. So then the answer is going to be x over negative 4 e to the negative 4x. Alright, the antiderivative of e to the negative 4x is negative 1/4 e to the negative 4x. So if I multiply the 1/4 and the negative 1/4, I get that. Okay, let's look at another one. Alright, think about Lyautey. In this problem, x to the 4th is algebra, ln of x is log or natural log. That comes first, so that means u is going to be natural logs, and v prime is going to be x to the 4th. Now the reason it works that way on this one is because I know the derivative of ln of x. The derivative of ln of x is 1 over x. I don't know the antiderivative, so there's no way that ln of x could have been v prime. Because with v prime, I have to find v, and that means find the antiderivative. So it's x to the 5th over 5. So uv minus the integral v u prime. Now I'm going to multiply that together. 1 over x times x to the 5th over 5. That makes x to the 4th over 5. So alright, the antiderivative of x to the 4th, I'm going to leave that 1/5, is add 1, so it's 1/5 x to the 5th. So our answer is that. Okay, let's do another ln problem. Alright. U and v prime. Ln comes first in Lyautey, so that's our u. And our v prime is x to the 3rd. Alright, u prime, the derivative of ln of something is 1 over the something, but then I'll multiply by the derivative of that. So that's 2x over x squared or 2 over x. If you simplify it, it makes the problem a little bit easier. Antiderivative here, so it's x to the 4th over 4. Alright, now for my formula, uv minus the integral v u prime. So the x's, I'd make a x to the 3rd, 2 over 4 would be a half. If you want to put it on the outside just because it might make it easier, you can do that. So we have ln of x squared times x to the fourth over 4 minus a half times antiderivative of x to the third is x to the fourth over 4. So we have ln of x squared times x to the fourth over 4 minus 1/8 x to the fourth. Let's see. Now, that's the basic kind of integration by parts. But there's another method that you can use on some of them. You can't use it on all of them, and I'll show you why. Let's say that you have the integral of x squared e to the x dx. If I actually worked out this problem with integration by parts, I would have to do it twice because of that x squared. But there's this other method. Some people call it the tabular method. What you do is you have u and you have v prime. And what you do is you start off by picking your u and picking your v prime. Just like we did with Liotte, algebra comes before exponent, so algebra is the u. And then you find, on the u side, you keep finding the derivatives until you get down to 0. So the derivative of that's 2x, and then 2, and then 0. On the v prime, you find the antiderivative, and you keep finding it as many times as you had to get down to the 0. Now, what you need to know is you can only use tabular if you can get to 0 when you do the derivatives. So only if you can get down to the derivative equals 0. If the derivative will never equal 0 after you keep taking the derivative lots of times, then you can't use tabular method. And this is in lieu of doing what you did in number 1 and number 2, because number 1 and number 2 could be done this way. Now, after you have this table, what you do is you multiply the first u with the second thing under v prime, and then the first 2x with the third thing, and then the first 2 with the e to the x. So we have x squared e to the x, and then 2x e to the x, and then 2 e to the x. And the signs alternate. The first one is positive, the second one's negative, and the third one's positive. First one is always positive. If there was negatives or something on those others, you would multiply that by those. But in this case, it's going to be positive, negative, positive, plus c, and so that would be the answer instead of having to do what you did in number 1 and number 2. Let's do another one. Alright, that's number 5, so let's do another one. Number 6. The integral of x squared minus 1 times sine of 4x. Alright, we're going to try it with the tabular because I know that if I keep taking the derivative of x squared minus 1, that I get to 0. And so I'm going to let u be x squared minus 1. I'm going to let v prime be sine of 4x. Now I'm going to work out my table. And honestly, I should have written the u above it instead of beside of it. Because in the table you need it written that way. Alright, so on the u side, just find the derivatives till you get down to 0. On the v prime, you got to find the antiderivatives. So you have to think about the u substitution with that 4x. This would be 1/4 negative 1/4 cosine of 4x, because the antiderivative of sine is negative cosine. And then the negative here would be 1/4 negative 1/4 times 1/4 cosine of 4x, or negative 1/16 cosine of 4x. And then the antiderivative of cosine is negative sine, so this sign changes again. Multiply by another 1/4. That would be sine You know what? I didn't even change these. I'm sorry. The antiderivative of cosine is sine. Antiderivative of negative sine is positive cosine. There we go. Alright, so that multiplies by the next one, so you just skip this first one, you just always skip it. So we have x squared minus 1 over 4 cosine of 4x. Multiply there 2x over 16. Well, that's going to be negative 1/8 x sine of 4x. And then 2 over 64 would be 1 over 32 cosine of 4x. And I need to go back and think about the signs a second. The first one's positive, so that's just multiplied by negative, so it's still negative. The next one's negative, multiplied by negative, so it's positive. Next one's positive, everything else is positive, so it's still positive, plus c. Okay, there's still one more method I want to show you, but before I do that, I'm going to give you 2 try problems, and they're based on the first kinds of problems that we just did. I promised you on the first one you can use tabular. On the second one, this one you can't use tabular, and the reason has to do with that ln of 2x, because ln of 2x can never be the v, because we don't know the antiderivative of ln of x. Although this comes down to equal 0, this doesn't. And so on the second one, you have to work out the long way. Okay. Now I want to show you one more kind of problem, and we'll be practicing more with it, but if I can go ahead and show you, it will make things a little bit easier. So try those 2, and then we'll get to the last example. Alright, so we're going to do the integral of e to the x sine of x dx. Now, if you think about u and v prime, and you find the derivatives and antiderivatives, neither one of these ever go down to 0. That means it looks like we're going to have to do this the long way. So let's pick our u and our v prime first. Think about Lyautey. We have a trig and we have an exponential. The trig is first, so trig is u, and v prime is going to be e to the x. Alright, the antiderivative, or the derivative of sine is cosine. The antiderivative of e to the x is e to the x. Your formula is uv minus the integral of v u prime. Now, the weird thing here is that we don't know how to solve that. So we're going to have to do this integration by parts thing again. Our u is still going to be cosine. V prime is going to be the e to the x. The antiderivative is negative sine x. The derivative is e to the x. So we have uv minus the integral vu prime. Alright, this first e to the x sine x, it just comes on down. Okay, uv is e to the x cosine of x minus the integral vu prime is negative e to the x sine x. Alright, it still looks like it's a problem we don't know how to solve, but we can. So before we do this, we're going to simplify a little bit. We got e to the x sine x, and we'll take this minus to both things. So minus e to the x cosine x. And then there's this other minus here, so minus e to the x sine x. So you've got the negative, and the negative. That's where the negative comes from. Now, the problem we were trying to solve was e to the integral of e to the x sine x. And so far, we have it equaling e to the x sine x minus e to the x cosine x minus the integral of e to the x sine x. And make sure that's right. 2 minuses there, sine, cosine, and then sine. Alright. This is really weird, but what you can do is you can take this integral and you can add it to both sides. On this side, we end up with e to the x sine x minus e to the x cosine x. But over here, there's 2 integral e to the x sine x. Last thing we can do, we're trying to find the integral of e to the x sine x, so what I can do is I can divide both sides by 2. And then we have an answer. Kind of a very strange process, and we'll do some more with this one. Of integration by parts, I would say this one is the hardest one. Go back and try the other 2 try problems.